Welcome to Scientific Computation using Python. In this video, I would like to show you operations with vectors, how to draw a vector, how to find its magnitude, how to find the angle between two vectors, and more. Let's start going back to Python IDE. Okay, we start by the regular imports, NumPy and Matplotlib pyplot. First, I would like to show you how to draw a vector. In order to do that, I would start with a figure and axis plt subplots and axis set aspect to 1. So these two lines, I need these two lines to make sure that my graphics output has the same aspect in the x and y. This is important when you do the vectors because the directions of the vectors, in order to get them right, you need the aspect ratio to 1. Okay. Now, let's also set the limits of my graphics. X limit, let's do this from -3 to 3.0, and I would like to use the same for the y limit as well. Okay, so this is my these lines is not about vectors yet. I am setting the graphic output x limits and y limits and the aspect ratio to 1. This is exactly the same we have done in the previous videos. Okay, at this point we want to create a vector and then draw it. So let's do a simple vector with in two dimensions. We have two components, ax and ay. So let's do a vector with 1 and 0. So the x component is 1 and the y component is 0. I can have another vector bx, by. This time let's have this vector 0 for the x component and 1 for the y component. Now I want to draw these two vectors to show you how the vector drawing function qver works. So to draw a vector, we do plt qver. Now first we input the coordinate where you want to draw this vector. I want to do it on the origin, so that's 0 and 0. Then I put its components ax and ay. Okay, we are ready to run this, so let's have a look what it looks like. Now at first the vector looks it is drawing the vectors, but we need two more parameters to make it look better. So that is we use scale 1 and units xy. This will make my vector scale to my axis over there. So if I run it again, okay, now this vector looks okay. So its x-axis is 1 units and that corresponds to this there. Okay, so for my y vector, let's change this to 2 and then plot it using the same function qver, so bx and by. I have scale 1 there, units, and then moreover I can supply a color code as well. So let's plot the second one in red. So here is my second vector over there. Okay. Now basically I am drawing vectors with I can set its colors, etc. And the important thing is they are scaled to the axis here. Now I want to do two random vectors. Let's, instead of 1 and 0, let's make this a random vector. And I just need to supply two random numbers as ax and ay. Let's see what this looks like. So this small one is my random vector. Okay. Because I use normal distribution, the vector can be in any of the quadrants. Good. Now we have a framework in which we can set vectors and then draw them. Now we have the basic vector plotting done. I want to show you, instead of working with two variables, I can set them to another variable b. So you are not maybe you are not familiar with this representation. This is basically two random numbers are set as ax and ay, and in turn those two numbers are set to a. The same goes here. I have my 0 and 2 as my components, and they are set as bx and by, and that is set as b. So I can run this in the same way. I want to show you what a is. So a has two components. Ax is the first one and ay is the second one. Likewise for b, bx and by. So it's much more compact to work with a's and b's as my vectors. So basically a is my first vector and b is my second vector. Now in the next part I want to calculate the length of a vector, and I will be using a and b directly instead of supplying the components separately. That makes programming and modifying code much more easier. So let's do that. Let me clear the console. I want to now find the length or the magnitude of a vector. For that, I want to do a function. Let's do a length function. Now this is going to input a vector variable. I need the components of the vector to do the length of it. So I say ax and ay is equal to a. So this is like taking the things out of the box and setting them as ax and ay. So the length should return ax squared plus ay squared, and then the square root of this. I want to do it this way. Okay, so this function takes in a vector and returns its magnitude, ax squared, ay squared. I think it should be obvious at this point why I am using a and then assigning them to a directly. I want to work with vector objects if possible. So my function is defined. Let me okay, here let me print the length of a, and in the next line I can print the length of vector b. Next I want to format them as well. So length of b is 2 and length of a is 0.8 03, that long decimal number. So I want to format it and put, so length of vector A is, so I can format it here. I want to do, oh, okay, so this will make it look, okay, so I want to spare 5 decimal points, including the dot, and 2 of them will be for the decimal points, 5 for the whole number digits, including the dot. You should be familiar with this representation by now, so I am not going to spend more time there. Okay, so let me run. Okay, 2 vectors. The length of vector A is 1.11. The length of vector B is 2.00. Okay, good. So this is defining a function to get the length of a vector. How can I get the unit vector corresponding to a vector? I want to define a function for that as well. Define unit vector. So this function will return a unit vector along some given vector A. In order to do that, I need basically I must divide the components of vector A by its length. So I have already defined my length function, so I can get my length with this one. And before that, I can deconstruct A, get the components from A, get its length, and then return the unit vector as AX over L, AY over L. So this function will return a unit vector. I am dividing the components of this vector by its length to get the unit vector. So in this case, let's change this program a little bit to make B the unit vector of A. Okay, look at this. I am making vector B a unit vector along A. We should be able to, so B is a unit vector along A. So let's see that. I should have my Bx and By here because I need this for to plot the next cube plot. Okay, let's run it and then describe what we see on the screen. So this is color black, the one on the top. That's my vector A. So the magnitude of vector A is 1.46, and this is what I see over there. And the length of vector B, which is a unit vector along A, is 1.00. So that's a unit vector along A. Next, I want to find the angle between any given two vectors. I will be using this formula. Theta between two vectors is arc cosine A dot B dot multiplication over the length of A times the length of B. Okay. Again, I want to do a function, define angle between, let's call the function angle between. Now I give two vectors A and B as parameters. So this function takes in two vectors A and B and returns angle between them. So let's begin by deboxing, taking the components out of A and B. Okay, remember I need the length of A and length of B vectors. So let's call them length of A. I have the function defined, so this should be easy. LB is the length of the second vector, length B. Now I can calculate the angle between. So angle is from that function numpy arc cosine. Now the dot product of two vectors is easy if you know the components, because you just multiply the components ax bx plus ay by over the length of these two vectors according to the formula. So here is the, I need another parenthesis. So the arc cosine of the dot product over the length of the two vectors, and this should give me the angle in radians. Let's let's run the program and see if we have done this correct. So I have a random vector and a unit vector there. I am outputting its lengths, and in addition I want to do angle between A and B is, so here is angle between A and B. Okay, I need, it will be better if I format this, but I want to run it as it is and then decide on formatting next. Okay, because B is the unit vector along A, the angle between them is naturally 0. This is good. Okay. Now let's set B as a different vector so we can, okay, let's look at this and then let's see if the vector, yes, now the vectors are not exactly pointing in the same direction and the angle in radians is 0.06. Let me run it again. Okay, 0.9, this is a larger angle, and then this is even a larger angle. It seems it is running properly, but at this point I can format it. 5.2f should be okay. Okay, so it is putting the angle in radians. So let's run this again. Okay, I want to change this function a little bit so that I can get the angle in degrees if I can. So radians, I want to supply another parameter as radians and then say true. So if radians is true, then I will output the angle in radians as it is the case. But if radians is not true, then angle, so I want to convert it into degrees. That would be angle times 180 or angle over pi times 180. So this should give the angle in degrees. If this is, I think this way of defining it is not really intuitive, so I should do degrees, and by default it is false if degrees true, then angle this way. So if I don't supply this, it is automatically radians as the program is running. So this is in radians. The angle is given in radians here. If as a parameter I say degrees is true, in this case the angle should be in degrees. So here is the angle in degrees, 101. So this is 101 degrees. Let me run this again. So this is 22 degrees. This is 161 degrees. And this is about 180 degrees. Okay, now our function is working properly to give us the angle. By default, it is given in radians, and if I supply a parameter, it also gives the result in degrees. In this part, I want to find the projection of a vector along another one. So I have a vector A, another vector B, and I want to find the projection of vector A along the other vector B. So in other words, I need the unit vector along the second vector, and I do a dot product to find the magnitude of the projection vector. So here is your A and the unit vector, and this is the projection of A over the U vector. So let's go to our code. Here is my new function to do that. Projection, to find the projection of vector A along B is therefore should look like this. First of all, I need my components as always. Now for the B vector, I need the unit vector along B. So first get the unit vector from our unit vector definition, unit vector function there. So let's call it ux and uy, the components, and unit vector from B. Okay. Now, therefore, this projection function, I am writing it in general, where B is not a unit vector. If B is a unit vector already, this line will not do anything to vector B, but still assign the values to ux and uy. Okay. Now, the magnitude of the projection will be the dot product as I just showed. So I can just return ax ux plus ay uy. So it looks very simple, but let's go over it again. So I get the components of A, and then I get unit vector along vector B, and the projection it is the dot product as I have shown on the slides. So how can we see how this works? Let me change this program a little bit so we can demonstrate the use of the projection function. So this is my A vector, a random vector. And then my B vector, let's make it a unit vector along the x-axis. So I have my A vector color. Let's make that color black explicitly. And the unit vector, let's make it gray. So printing the length and the angle, I can still do that. So let's first see these two vectors. So this is my A vector and this is the unit vector along the x-axis. So now to do the projection of A along the unit vector, I need to do something like this. Plot curve at the origin again. Now the length of my projection must be along the unit vector. The projection of this vector along this direction is, of course, can be described by the unit vector. So here is ux and uy. The only difference is the scaling. So my projection will be a magnitude that scales these two vectors, projection and projection. So basically I have my ux and uy unit vector, and I am scaling it with the projection scalar. So let's do the same description as I do here and use a different color. Okay, in this case, let's do a blue color. Now the projection scalar, I get it from my projection function, projection of A along B. My B vector is already a unit vector here, so the function, this line, will basically get the components. Ux and uy will be bx and by. Okay, ux and uy. Okay, I see ux and uy not defined here, so that is my B vector. I must get ux and uy from my B vector. So this is not inside the function. So I must get them explicitly. So unit vector from B. Okay, now that warning is off. Now let me run this. Okay, here is my A vector. And then this is the unit vector, and the blue vector is the projection of A along the unit vector. Let's run it. So here is my original vector A. Because there is a greater angle than 90 here, the projection is in the opposite direction to my unit vector. Run it again. Okay, the same. The angle is greater, so the projection is on the opposite direction. Now, next I want to do the B vector, also random. So I have my A and B as general vectors. So here is your A, and the projection of A along this vector is in the other direction. So run it again. Okay, it's small, so I can't see it. Wait. Okay. Okay, my vector the B vector, and this is the projection. Before I finish this part, I want to show you another parameter here that sets the transparency. Alpha equals 0.5 will make them halfway transparent. So this is sometimes really handy. So here is another alpha 0.5. This will make, when the vectors are on top of one another, we can see them through by making them transparent. Okay, so here we can see the vectors better. So that's the B vector and the projection. Okay, this is all about the basic vectors. Next, I want to go plotting multiple vectors.